Okay, so first and foremost, want to say hello to everyone that is here for this A-Math session. So the Sec 3 Head Start program for A-Math. So let me first introduce myself. Who am I and what my objective here is today, and then we shall kickstart the session. Okay. So hope everyone can see my screen. If let's say it's a bit too small, do let me know in the chat. Then I can resize and I can try to fix that problem. Okay. So let's begin. So my name is Kaiwen, and I'm Overmark's A-Math and E-Math tutor. So I teach both Upper Sec A-Math and E-Math. So today my objective is to actually give you guys a little teaser of what A-Math is. So A-Math is a brand new subject that everyone will be taking. So yeah, what I'm going to do today is not much content teaching per se, but to give you guys a little taste of what additional mathematics actually is like in the upper sec level. So I will also be trying to cover as many questions as possible. So questions that you guys have with regards to the new subject. So if you have any questions with regards to like, oh, is the subject difficult, or do you feel that how can I improve or whatsoever, there will be a Q&A session at the very end. So the last maybe 15 to 20 minutes. So if you have any question per se to the subject, or you want to clarify anything, you can head over to the Q&A session to settle that. Okay, so let me carry on. So I teach group tuition. So that's my objective also, is to get students for my group classes so that I can guide you along for the Sec 3 level and also your Sec 4 before you take your O-levels next year. Okay, so yeah, some background about myself. So I'm from NTU. I'm in my third year this year and I study mathematics. So I'm one of those weird people that love mathematics a lot. And yeah, my research interest is more on the pure mathematics side. And I like all those kind of geometry stuff in the topological sense, surfaces and whatsoever. So this one, if you're interested, you can go online and have a read. But do note that yeah, it's a bit chim lah. Okay, that is really different from whatever we are going to be studying today. Okay. Now, today's agenda. So if you were here for my E-Math session yesterday, I will be doing something similar to yesterday's session, but also be a little different. So for yesterday's session, the beginning first like 20 minutes, I went through some Sec 2 questions, but for today, I cannot do that because there are actually no questions that you guys can do because this is a brand new subject. So instead, what I'm going to do is I'm going to show you guys all the different topics and give a little introduction to every single topic and give you guys an idea of what direction that we will be heading towards taking A-Math. Okay, I will also be doing a little comparison between E and A. Okay, so you guys will know like, oh, what's the main differences between the two subjects and what to actually look out for when studying A-Math. Okay. Next, I'll also be telling you some of the hardest topics. So some topics to take note of because these are like common loopholes that a lot of students need to take note and focus on these topics when you're ever covering it in school. Okay. Then what I will do is that I've already sent out the lecture notes that I will be using today for simultaneous equations. So I chose a really simple topic to start off with. So the notes have already been uploaded. So if you're interested, you can go and take a look. Later, in the later half of the session, we will be using these notes and I will be going through a little bit of the content in this chapter. Okay, so let me first talk a bit about the syllabus. So this is the main syllabus. If you didn't know, you can always refer to the SEAB syllabus guide. So go online, go into SEAB, search for the Additional Mathematics 4049 syllabus. That will be the one that will be in 2 years' time, the O-level paper. And these are all the topics that you'll be covering. Now, I know what you're thinking. I'm going through simultaneous equation, but there's no topic simultaneous equation. Okay, that's true. The reason is because it is actually hidden in one of the chapters here. Now, if you see from the table, you see two colors. Okay, the white ones, which I didn't highlight, and the ones in yellow. The topics in yellow are actually for Sec 4. So you will only cover these topics here. So let me use a thicker pen. These topics here in Sec 4. So Sec 4. The remaining 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, these 10 topics will be covered in Sec 3. Now, it really depends on your school. Some schools do not teach Trigo in the first year because it's a little bit more difficult, but some schools do. Majority of the schools that I know, they do teach all of these how many chapters again? 2, 4, 6, 7, 8, 9, 10. 10 chapters within the first year. Okay, so let me give a little breakdown of what everything is going to be about. Okay, so if you have already been reading the textbook, okay, for some really into people, I hope that the textbook is interesting and you have a little sensing of what things are. But from what I understand, most students that start off with A Math will get a shock because it's like, oh my God, why is it so complicated, so different from lower sec math? Now, this is a fact because lower sec math gears more towards the E math side of things, while A takes a little bit of a different turn towards mathematics. Okay, so let me give a little summary of each chapter and give you guys a little sensing of what you will be covering next year. So we start off with quadratic functions. So I think everyone here already knows what is a quadratic function. So a quadratic function looks like this. Let me write it here. Y equals to ax squared plus bx plus c. You will learn a little bit of the intricacies on what entails a quadratic function. So you will understand why is it an a, why is it a b, why is it a c, and you will also understand the concepts of why a curve is floating above or underneath. So these are the two main things you will learn in this chapter. Okay. Next is equations and inequalities. So these are functions, so they are slightly different from equations. Equations are okay, I mean, I'm going to write it in the exact same way, okay, but they are slightly different in nature. So when you hit on to the first chapter, you will actually know what is the main difference between the two. Okay. Oh, the worksheet, is it? Give me a sec. Okay, I'll put out the link for you. Sorry, give me a sec. Okay, hang on now. Link. Where are you? Where are you? Gotcha. Okay. Yeah. Oh. Okay, so I just sent out the Dropbox folder. Inside will contain the chapter notes for Sec 3E A Math. So you can look for that folder. You can go and download the lecture notes, but I'll be using them like at a later stage of the session. Right now, it's just a little introduction to every single topic. Okay. So you will understand the intricacies of how to solve quadratic equations using the box, using the quadratic formula. You will also learn completing the square. So completing the square in this chapter, and you will learn about inequalities. So inequalities is something that you have learned in Sec 2 math, which is the relation symbols like this. But this one, you will learn how to solve quadratic inequalities. So that one needs an additional layer when you're learning about inequalities with quadratic functions inside. Okay. Now, there will be some chapters inside here where you can link to your lower sec math, and I'll actually tell you where these are. But it's not a lot, but some are actually hidden around. And another beauty of this A Math is that everything that you have learned in E Math is assumed knowledge in A Math. So whatever you learn in E, you cannot throw away because you will need it again in A Math. Okay, the concepts are linked. Some of the formulas from E will be used in A, but you will never see A Math formulas in E Math. Okay, so it's a one direction way thing. Okay, so we're going to the third chapter, which is Surds. Now, Surds, if you have never seen this word before, actually it's something that you have covered before. It's about square roots. So you will understand the natures of root 2, root 3, how do you manipulate roots? So like, for example, how do you simplify root 48? You will learn how to do that, and you will learn how to play around with all these kind of roots, and you will also see root x, root y. So I don't think you will see this in lower sec, but you have seen the square root symbol before. This is the chapter that we will play a little bit around with. Okay, polynomials. So polynomials should be a new term that majority hasn't seen before. What is the definition of a polynomial? It's basically an equation that has a degree, higher power. So for example, y equals to x cubed plus x squared plus x plus a. So the max that you will ever learn is only x cubed. So you will learn the natures of a cubic function. So cubic, okay? So just now initially I talked about quadratic. For this case, you will learn until x cubed. And you will actually learn how to solve a cubic equation. So that is pretty cool. So you have a straight full equation. You're able to break it down into 3 entire parts. So this is the chapter. Now within polynomials, you will actually have simultaneous equations as well. So there is the simultaneous, so sim equation. Now this simultaneous equation is pretty similar to the EMath lower sec content, which is the substitution and elimination portion of the chapter, but there is one additional layer now. In this chapter of simultaneous equations, you will deal with quadratic functions. So you will see functions that have an x squared. How do you deal with that? Or you will see things that combine like trigo, or you will see things that combine with the other chapters inside here. That's why this is a quote-unquote more difficult version of the lower sec simultaneous equation. Okay, but don't need to worry. The portions that I'll be covering today is really simple. And why is this the opening chapter? I know it's a bit strange, right? That I didn't choose quadratic functions as the opening chapter. There's a reason why. Because in order to solve quadratic function questions, or to understand why a curve is floating above or below the axis, you need elements of simultaneous equations inside. So no choice, this has to be the opening chapter. And that's why this is what I will be covering today. Okay. Next is partial fractions. So partial fractions is the study of how do you split up really complex fractions. So I'll give you an example. So x squared plus 4 divided by x cubed plus x squared plus x plus 9. So sometimes in exams, you'll be given a fraction that looks like this, and your objective is to break it down into simpler things. So like for example, I'll give you an example. Half plus 1/3 is equals to 5/6. Okay. Now the question will tell you, I give you 5/6. What is 5/6 in its simplest form? So it's essentially half and 1/3. You will actually learn how to get these two things out from this kind of functions. Okay, so this is partial fractions. Okay, 2 more chapters at the bottom. So binomial theorem, exponential, and logarithm. So these 2 are the ones with the English words a little bit more scary, things that you haven't seen before, but it's okay. They are not super difficult. So for binomial theorem, what is it? Okay, actually you have actually seen it before, but in a different context. So let me show it to you. For binomial theorem, you have seen this, right? A plus b squared. So in Sec 2 math, your algebraic identities, you have seen a plus b squared, which everyone knows is a squared plus 2ab plus b squared. Okay, now in this chapter, you will not only learn a square, you will actually learn 3, 4, 5, 6, 7. So things you will see is like a plus b to the power of 7. Oh, and then you will be taught how to expand this out and how to find terms within. So it's tapping on a little bit to what you have learned in Sec 2, but now you're just extending it a lot more in EMath in this chapter called binomial theorem. Okay. Next is exponential and logarithm. Okay, so 2 things also sound very scary, okay, but don't need to worry. I'll explain what these are. So for exponential functions, what these are. If you look onto your calculator, so I'm going to pull out mine. Okay, this is my calculator here that I've been using since secondary school, like 7, 8 years ago. Okay, if you notice, if you're using the Casio calculator, there is this button right here. If you press Shift and the long button, you will see this, e to the power of a square bracket. Okay, so this is the study of the letter e. E is an exponential function, which is about 1.6 something, 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 something. So you will learn how to manipulate them. You will learn what is the graph of an exponential function. And you will also learn some pretty cool things. Like for example, radioactive decay. When something starts to decay, you will follow a function and you will follow this letter E. So you will learn how to play with all this and you'll learn how to solve equations as well. How about logarithms? So this one looks scary, right? Okay, same thing on the calculator. You're able to find it. Remember the button that I mentioned just now? So this button here, instead of pressing the shift, you can see there's an LN. This is log and LOG, which is the button right next to it is log, LOG. So you'll see this and this. Okay, these are the two new functions that you will actually see, and you will learn how to manipulate equations along with them. Now, inside my simultaneous equation notes, there's actually an equation there that looks like this. Later, I will talk a little bit about that. Okay, so this is the whole algebra section for A-math. So whatever you have covered whatever I have covered just now, you will roughly take about 6 months in school to actually finish. So pretty fast, you will be able to clear all of this pretty quickly in school. Okay, after this, I will tell you which are the scary topics. Okay, so that will come in a short while. Now, we'll go into geometry and measurement. So that is the new core. So for me, what I do is that I split up the subjects into 3 different sections because they are all 3 very different things. Number algebra. So this is the algebra portion of the chapters, which I have just covered. Geometry and measurement. So that involves like your circles, your triangles, squares, your coordinate geometry. This is under this portion. And you have calculus. So calculus is something later I will talk about. So let's start off with Trigo. Now, I know most of you like forced to take A-math because your schools like force you to take A-math. Okay, A-math is a subject where a lot of people get very scared of because they feel that they cannot do it. But trust me, A-math is actually a very repetitive subject because the questions cannot change that much. If you study well enough and you have seen majority of the question types, you will be safe from exams. Okay. So let's start off with Trigo. So in lower sec Trigo, we all know these, right? Sine, cosine, and tangent. Okay, this is lower sec Trigo. Now in E-math Trigo, you will actually learn a few batches of things. So you will learn like bearings, you will learn shortest distance, angle of elevation, angle of depression. So those are the application based in Trigo. But in additional mathematics, you will learn something slightly different. So let me introduce a little bit. So we all know the base 3 Trigo ratios, sine, cosine, and tangent. But do you know there's actually 3 more? Secant, cosecant, and cotangent. Okay, you will be introduced to these 3 new trigonomic ratios. So for those people that Trigo very not good on, right, you start to sweat. You got another 3 more to memorize. Okay, don't need to worry. It will be safe. Okay, don't need to worry too much. So there will actually be the introduction to these new 3 ratios, and you will learn how to manipulate formulas. You will learn how to sketch the graphs, and you will learn how to play with all of these Trigo functions. Okay, this is the base of what I can tell you for now, but this is a really huge chapter and takes about a month to cover in school. Okay, coordinate geometry and further coordinate geometry. So what's the difference? So coordinate geometry is pretty similar to the E-math coordinate geometry. So this is a good thing. Whatever you study in E-math coordinate geometry is pretty close to the A-math one. The only main difference is that you learn 2 additional formulas in A-math. And the questions, of course, steps up in difficulty. Okay, so if in case you don't know what is coordinate geometry, let me explain. Okay, you know your graph looks like this, right? We call this the Cartesian coordinate system. So y and x. So what you will learn in this chapter is like I give you a line. Okay, and I tell you some very special property of a line. And I ask you to find a point. This is this chapter. Then maybe like, okay, all these lines, I draw these lines here, and then now I have a shape in the center. Okay, the questions will ask you to find the area of this shape that's being formed by all of these lines. This is what you will learn in coordinate geometry. Okay, we call this the Cartesian coordinate system. So this is a little bit chim. Cartesian coordinate system. Okay, Cartesian coordinate system. Now, in further coordinate geometry, okay, we are just extending a little bit. Now you realize here is all straight lines. There's a class that we haven't touched yet, okay, which is circles. So we are all going to learn about the beauty of circles. So you will learn what is an equation of a circle, and you will learn how to manipulate these circles around. So like I move the circle here, I move the circle there, I grow the circle, I shrink the circle. This is this chapter. Okay, so pretty much whatever I've just covered here is whatever you are going to be learning in Sec 3. Okay, so pretty much all of this stuff lah. Okay, so I hope I didn't scare you. Okay, but this is primarily what you're going to be doing. Now let's talk a little bit about the 5 yellow chapters. So these 5 yellow chapters are in Sec 4, and they are a step up in difficulty, of course. So let me introduce a little bit. Linear law. So what does this mean? The basic understanding of what linear law is about converting a funny equation. Let's say y equals to abx. Okay, and in this chapter, I give you this. Your objective is to make this line straight. Okay, something called a best fit line. Don't know whether you've heard before. Okay, in your sciences, like for example, you're plotting data after doing an experiment, and then you need to join using a best fit line. In A math, you're actually going to learn how to actually sketch this best fit line, and how do you convert this kind of funny graph shapes into a straight line. And this is the arts of linear law. Now let's skip proofs of plane geometry first. We move on into calculus. So this is the very last core, and this will usually take up about 2 to 3 months in school, because this is where all the monsters from under the bed will start coming out. And this is the first introduction of some of the more complex concepts in the A math syllabus, okay, which is differentiation, integration, and kinematics. Okay, now when I first introduced kinematics to some people, right, people were shocked. People thought that kinematics in physics. Now that's true, but what you will actually learn is the math calculation portion of kinematics. But it's okay, I'm jumping the gun. Okay, let's go into differentiation first. So what is differentiation? Okay, so the easiest way to explain what is differentiation is that if you're given a curve, okay, I want to find what is the tangent line or a line that cuts this curve exactly once. This is the main study of what differentiation is. Okay, it's a bit difficult for me to actually define to you what is differentiation, because you do need a little bit of prior knowledge, but just take it at face value first. Okay, don't need to worry so much. Now, integration is another direction. Okay, so we are given a graph. Integration is about finding how to find the area underneath a curve. So it's like this. Okay, so this is integration. And then for kinematics, you will learn about the distance, speed, and acceleration formulas, and how to move around them in equations and questions. Now, if you realize that I'm just saying one-liners about them, because these are really far down the line, so in a year's time, so I don't want to scare you guys, I don't want to flood your brains with like unnecessary knowledge here. So that's why I'm just going to leave these two for the future, whoever is going to teach you for them. Okay. Now, I know I skipped this chapter here, proofs in plane geometry, because this is a devil chapter. So I put a sad face. Okay, the reason why is because this is a difficult chapter, and you will see it in my next slide. So what is this? Okay, so basically what this chapter is about is that you're given a triangle, you need to prove that this triangle is isosceles. Or you're given a circle, you need to prove that 2 lines in this circle equals to another 2 lines. This is the art of this chapter. Okay, you will definitely learn how to do it, but it will take a bit of effort. And this is actually the really last chapter for the whole syllabus. And there is a reason for it, because it's the most difficult. Okay, so the yellow chapters, let's not focus on them. We just talk about the ones in white, because these are the ones that you will be introducing first, you'll be getting to know first in school in the next 1 month. Okay, so I hope this summary has been interesting. It piqued your interest. It's either it piqued your interest or I scared you into taking A math. Okay, but don't need to worry. Trust me, A math is not as difficult as it seems. A lot of people say that, oh my god, A math is so tough. Oh my god, A math is like death. So or oh my god, A math is something that I cannot do. Okay, it's not true. Yes, I can screenshot. Later I'll screenshot and I'll upload it. Okay, so I know like whatever I just said is like, oh my God, so much new stuff to learn. Okay, but don't need to worry. It's a learning process for everything. Trust me, like 3 months before your O levels, right? You will realize like half of these topics are chicken feed and they are so easy to do. Okay, because right now you are at the really, really tip position at learning the subject. That's why everything looks like, oh my God, so scary. Okay, but don't need to worry. Trust me, don't need to worry so much. I love AMF. So AMF is like one of the subjects that I love to the core because it's super fun. Okay, I hope that there are people out there that should share that sentiment with me, okay, and love mathematics like how I'm taking math in uni now. Okay, but if you don't, I do hope that whatever I just mentioned can actually pique your interest in math and also like give you some understanding of what math is going to be like in upper sec. Okay. Now, topics to look out for. So these are the what I call quote unquote the really scary topics in upper sec. So these are the topics that I know students struggle a lot because either they never learn it well in school, the schools don't teach it well enough, or it's either like you never concentrate in class and then you lose focus, you cannot solve the questions there. Okay, and these are the chapters that hold a lot of weightage in the papers. So let me tell you a little bit about that. So in the AMF papers in O levels, you actually sit for two papers. So paper one, sorry, let me write bigger. So you'll sit for paper one and paper two. Now in paper one is 2 hours and 15 minutes. Same thing for here, 2 hours and 15 minutes. Okay, this is about 10 to 12 questions, while this is about 9 to 11 questions. Okay, so there is a stark difference between paper one and paper two. The number of questions and of course the difficulty will be slightly different. Okay, paper one is 90 marks and same thing for paper two. Okay, so you might be thinking like, why got two papers? Okay, the reason is because there are so many concepts to tell. Even though I have only just these topics alone hold quite a lot of content. And it's quite a lot of content to learn within 1.5 years. So just take note. Okay. Now, what's the reason why I say these are death topics? And if you're not careful, you will have a lot of problem because all of these topics here, if you go and add up the number of questions that appear in paper one and paper two for the exams, this will constitute about 50% of the whole paper. Okay, so it consists about at least 50% of one paper. So that is a lot of content. Okay, like for example, in the Trigo chapter, there can be at least 3 to 4 questions. Exponential logarithm, at least 2. So that is why things are pretty scary for these chapters. If you fall behind in any one of them, yeah, you will need to go and pick it up and go and focus on these topics first. Okay. Now, of course, I'm not going to scare anyone, or I'm not going to like give you guys these topics now because they do need some time to build up. So I'm going to hold your hand through the most basic topic out there, which is simultaneous equation. And that is the chapter that you need to master first from your Sec 2 content before you bridge into Sec 3. Okay? So just some tips that I can provide for everyone. I know like I say you need to practice. Okay, this is a really important fact because practicing really makes perfect. So for AMF, especially AMF, you do need to focus a lot on practicing because this is where you get your repetitions from questions. And remember what I mentioned earlier, for AMF, all the questions are pretty similar. The question styles are always the same. As long as you have a grasp of what these question styles are, and what you need to do, you will be able to do it. Okay, so for me, what I do is that I see this question type, and I will remember in my head, oh, okay, I need to do this. Okay, I just regurgitate out on the paper, follow the equations and numbers on the paper, and get my final answer. Okay, so that is what I hope with a lot of practice, this is what everyone can do. Now, how to get revision questions? So that's a question that I get a lot. How do you get resources, or where do I find questions? Okay, so there are a few areas that you can do that. You can go online. So you can look for all of these chapters online. You can look for like online resources. You can look for school papers. You can look for me also. So I give out monthly practice questions as well with these topics inside. they are mainly catered to Sec 4, but those Sec 3 chapters, you can actually attempt the Sec 4 questions because the difficulty is about the same, to be very honest. Okay, so yeah, this is the main difference, or this is what you need for your revision. Now, some important tips. So what do you need to do? Okay, this is exactly the same as EMath because, I mean, they're maths. So first thing is to get your foundations right. So when I mean by foundations, I mean your Sec 2 content must be pretty solid. So you need to know like your basic math of like algebra, your basic simultaneous equations, all these must be pretty good. Okay, or you must be like you won't like falter under like any stress or what. Okay, and also the initial topics. So I will point out some topics to you that you need to secure right at the very start, okay, such that you will not snowball. So first one will be simultaneous, okay, and these two first topics here, quadratic functions and equations and inequalities. So this chapter here and this chapter here. Okay, these two are chapters that will link on to other chapters, and if you struggle right here, it will definitely snowball. So please focus your effort on these two chapters first and to prevent any snowballing from happening. Okay. Next is to clarify your doubts. So whenever you have any problems with AMF, you cannot do the questions right, always ask for help as soon as possible. It's either you try your really hardest to solve the questions or look for help. Ask anyone. You can ask around, ask your friends for help, or you can look for your teachers for help. Okay, because you don't want this to accumulate. Remember what I say? All the questions are pretty similar in nature. If you have one type of questions you cannot do, the chances are there will be questions that will come back and haunt you in the future. And you don't want that to happen in AMath. Okay. Last one is to be consistent. So what I mean by that is that always allocate some time to do math every single week. So for me, for Sec 4s that I recommend will be an hour a day. So an hour of E, an hour of A. But of course, it really depends on your subject combination. Some of you take like many subjects and you need to spend time on your other subjects as well. Okay, but you must remember that math at this particular stage is no longer where you can just go in and wing it. Okay, it's not possible. You do need to study because there is quite a bit of content to know and quite a lot of questions to actually get your hands around. Okay, so last time for me, my AMath, okay, of course, when I started my AMath, it was pretty good, okay, because I have a natural tendency towards math and I love math a lot. But I got friends that like struggled for math like crazy last time. And basically what my teacher told them to do was to just practice. So you just take questions and go and try. Anytime cannot do, go and find someone to help. And then once you practice, you go back and see the same question again, you confirm can do it. Okay, so this is the main advice for math. Now, let's talk a bit about like exam timetables and whatnot. So these are what your exams will look like. So usually by CA1 or your first semestral test, you will have covered, I think up to at least Surds. Okay, so at least the third chapter. Then by mid-years, maybe until like binomial theorem. Then your CA2 either will touch Trigo already, and then your end of years will have the circles there. So always pace yourself throughout the year. Make sure that you do not fall behind, because once you fall behind, it is going to be pretty difficult to catch up, and you will need a lot of effort to catch up. And it's honestly not worth it to go and like 1 month before go and start to stress over this subject. Okay, it's really not worth it. Okay. So Sec 4s, I think not really important. So, okay, I don't really want to cover this at the moment. So what I will do right now is that I'm going to go straight into the first topic, okay, which is simultaneous equations. I'm going to give you guys a little introduction as to what the chapter is about. And I'm going to go through like some stuff that you guys already know and touch a little bit of some new stuff, which is the more of the Sec 3 content for simultaneous equations. Okay. So, yep, these are the lecture notes. So the lecture notes are already in the Dropbox folder. So you can go and take a look at it. So all of the content has already been filled out for you. The only thing missing are the workings of some of the questions. So that one I will do live with you right now. Okay, and I will not be covering everything, of course, because there's not enough time. And I want to take my time to go through this. And also take note that this set of notes is not complete. The reason is because I've taken out things that are not really relevant to you guys right now at this stage, because this is the opening lecture on simultaneous equation. Okay, so let me take a sip of water and we shall begin. Okay, so you can download the materials inside the Dropbox folder. Okay. Okay, so these are the lecture notes. Okay, so I hope everyone has access to them. So clearly the title is Simultaneous Equations, and we're going to cover a little bit about what this is. Now, everyone already knows what is simultaneous equation, because this is a concept in lower sec math, and I think everyone already knows the elimination and substitution methods in simultaneous equation. Okay. So let me just read some stuff of my notes. So this is the cover page, okay, and the syllabus outline is what SEAB writes on their syllabus guide. Okay, so right here is about solving simultaneous equations by substitution, with one of the equations being a linear equation. Now, I know this is a bit chim, so let me explain to you what this means. Okay, now in the take note portion there, what I've written is that this is the opening chapter, like literally the very first thing they will teach you in school. Okay, the reason why is because you need the knowledge from this chapter to tackle other chapters in the future, which is like indices and logarithms. Without this particular chapter, you cannot cover the chapter in school. Okay, so there are questions inside this particular chapter that require the future topics as well. So that's why those questions you can't do. When you have learned the newer topics in the future, then you can come back and actually attempt the questions here. Okay. Now let's start. Okay. So this set of notes I think is about 12 pages long. Okay. Supposed to be about 20 plus, but I removed some stuff like that is not necessary, like I mentioned previously. Okay. So I hope everyone can follow me, okay, and I'll be annotating along these lecture notes. So anything that is important, I will highlight, and I will also be uploading these annotated notes onto the Dropbox folder. So in case I go a bit too fast, you cannot catch, you can refer to my handwritten annotations there, okay? Now, of course, these notes are what you're going to be getting if you continue on with me in a normal lesson. So every chapter will look like this, and you'll get formal notes, and you'll get questions, explanations to everything. Okay, so you see whether does this actually suit you or not. Okay, so let's go, simultaneous equations. So let's talk about the Sec 2 content first, because the first 1.1 and 1.2 are actually EMath and Sec 2 content. So I'm going to do a little revision first. Okay. Now, what is the basis of a simultaneous equation? A simultaneous equation, or a group of simultaneous equations, is you are given two equations with two unknowns, most of the time x and y, in both of these equations. Then your objective is to use these two equations, do some magic inside these two equations to get out the values of x and y. This is basically what is simultaneous equations. And if you didn't know, okay, the solutions that you get out from these two simultaneous equations, you can actually plug them back into the linear equations. And these will actually work out. So for example, I just have a hypothetical situation. Let's look at these two. If I solve these two, and the answer come out to be x equals to 4 and y equals to 5. Now, obviously, this is not true. Okay, I'm just saying. Okay, what you can do is you can substitute these x values into this equation, and it will work. And of course, if I've done it correctly, it should work here as well, because the solutions from these two equations must be the same. Okay, as long as you can support the substitution into the two equations, you know that you have gotten your answer 100% correct. Okay. Now, in this chapter, we will need to understand the main differences between linear and non-linear. Okay. So the opening chapter, they always say, okay, one of the equations must be linear. And what does it mean? Okay, I know everyone takes the word linear for granted, but you need to know the definition of what a linear equation is. A linear equation is a mathematical equation where the powers of the unknowns are degree 1. So if you look very closely here, this is a linear equation because your x and your y's are all single powers. So there's no square, there is no cube, there is no like funny terms inside the equation. You can literally sketch this onto a graph and you're going to get a straight line. This is also another definition. When you plot this, okay, you're going to get like this kind of graph. Okay, and if you plot this one as well, you're going to get a straight line graph. You will 100% get a straight line. That's why we quote unquote call it a linear graph. Okay, and these are linear equations. Now, in the study of this chapter, the A math portion of it, that is where you will see non-linear equations. So that one's on the later stage, okay, and we will touch on that later. Okay. Now, if anyone has any questions with regards to whatever I'm saying, you can hold your questions to the very end. Or if let's say it's like a burning question that you cannot understand, right, and you need me to clarify, you can type in the chat. Okay, then I will try my best to clarify. Okay. Now, in 1.1 and 1.2, I wrote there already, these are assumed knowledge from the E-math chapter. But the reason I put them in here is to make the chapter complete and make it a whole. Okay. Now, let's talk about the solving of simultaneous equations, because that is my objective whenever I'm given a simultaneous equation. Okay. Now, there are three methods, okay, that for solving simultaneous equations. Now, I know in schools, they always tell you there's only two, which is elimination and substitution. But actually, there is a one more, which I will talk about later. Okay, so let's talk about the most basic one, which is elimination. So what is elimination? Elimination is the process of eliminating an item. So it's to get rid of something. Okay, and what is the thing that you're going to get rid of? You're going to get rid of one of the unknowns. Okay, the reason is because if you have an equation with two unknowns, it is impossible to solve. Okay, because you have two unknowns. But if you do your questions correctly and you get rid of one of the unknowns, what you're left with is a single equation with one unknown. Let me demonstrate. So if let's say, okay, let's see, if I have an equation that states here, x plus y equals to 3, can you find the values of x and y? No, it's impossible because there are so many answers for x and y here. If you realize x can be 1, y can be 2, x can be 3, y can be 0, x can be 4, x can be 4, y can be -1. There are so many answers, but you cannot solve for x and y. But what happens if you have this? X plus 3 equals to 4. Like this, very obvious. The answer is 1. Because when you have one unknown in the equation, you can guarantee solve. When you have more than that, you cannot solve. Okay? So the art of elimination is about getting rid of it, of an unknown that you actually do not know. And how do you get rid of something? Most of the time, we will do a multiplication and division first. So you will either take something, divide throughout, or you will multiply an equation throughout to make a common term. And then after that, you go and minus or plus the two equations together. So this is step 1, step 2. Afterwards, you will get a full equation, and then you'll be able to solve for your first unknown. Okay, now I have a worked example at the back, so later I will demonstrate in case everyone has already forgotten what is elimination. So don't need to worry about that. Okay? Now, this is just a little note from me. So personally, I hate the elimination method. I'm going to be very frank. Okay, I've been doing math for so long, right? I completely hate the elimination method. The reason is because it takes a lot of effort. Okay, it requires a lot of work and it's not worth it most of the time. So for me personally, I will always do my questions in substitution unless it is super obvious. So let me demonstrate what I mean by that. So if I have an equation that is like this, 4x plus y equals to 6, and y plus 3x equals to 7. Like this, okay, fine, I will do elimination. Okay, because the y here and the y here, very obvious, I can just take the first equation minus the second equation, the y will vanish. Okay, But sometimes if let's say your equation becomes like that, 4x plus 17y equals to 231. 2y plus 19x equals to 643. You want to do elimination? Sure, slowly do lor. Okay, so you slowly go and find a common multiple between 4 and 19, or 17 and 2, and then do the elimination. Can, but a lot of work. So I personally don't like. And that's why I personally go for the substitution method. Okay, and also a point to take note, in A math, for simultaneous equations, we can only do substitution. So why study this additional method when both are using simultaneous, both are using substitution? Okay, so this is the reason why I preach substitution more as compared to elimination. Okay, so let's move on to substitution, my favorite method. Okay, which is the next page. So for substitution, what is it? What does it mean to substitute? Okay, I'll give you an example. If you play sports, okay, I personally don't, but I watch shows lah. Okay, so if you're playing like a soccer match, okay, like you have your favorite team playing out there, and then you play. A soccer match is usually like really long, right? Like 2 hours or something. I don't know. Okay, not important. But your soccer match is so long, you cannot expect someone to be running for 2 hours non-stop, right? Yes, there are people that can, but the layman cannot lah. Okay, so what we will need to do? Substitute. So they will substitute the tired person, ask the person to sit on the bench, and then you'll get a completely fresh person to go out onto the field. So what you have done here is a substitution. So this is what we're going to do. Okay, I'm going to be replacing whatever unknown and throw it into the equation, such that whatever I'm left with is just an equation with one unknown. Okay, this is the main idea beside substitution. Okay, so substitution also links to this concept, which is making something the subject. So make something the subject. Okay, so what this means is this. Let's say I have x plus y equals to 3, and I want to use either x or y into my substitution. I need to make x or y the subject. So I will do x equals to 3, minus y. Okay, so this is an example of what is going to making something the subject. Okay, and then what I will do is to call this an equation and then throw it into my other equation. Once you throw it in, okay, the whole equation will only have y, and now you can solve just like the previous thing. Okay, now let's talk about the last one, okay, which is this. Now this one is a little bit more different, so just take note of it. Now in schools, I know in schools a lot of people, they say simultaneous only got 2 methods. Okay, this is not very true. There's actually a third method, which is graphical. Okay, the reason why is because what are you actually finding? Whenever you are given a simultaneous equations and you're looking for the answers for x and y, actually you are looking for the point of intersection between these two lines. So let me demonstrate. So I have a line that looks like this, and I have a line that looks like this. Okay, and I'm just going to hypothetical call an equation now. Y equals to half x plus 3, y equals to negative 2x plus 7, for example. Okay, so I have these two equations here. Now, what is simultaneous? Okay, it's about finding this point here, finding the points of intersection. So sometimes questions will actually give you the two equations, ask you to plot it onto a graph paper, and look for the point of intersection. So what you're actually doing is looking for the solutions of the simultaneous of these two equations. Now, what's the reason why I mentioned this? Because there is a very special class of questions in EMath and AMath that talks about the solution of simultaneous equations. Okay, so this one you need to go and take it into Sec 3, and then you will know what I'm talking about. So this one I will not go into it because it's a little bit further down the road. Okay, but just take note, graphical method is only used when the question says so. So if the question never say, right, don't need to do, because no point. Okay, just do it the normal way and everyone is good. Okay, now let's do some work examples. Okay, so this is to go through back the simultaneous, the elimination portion and the substitution portion. Okay, so for example 1.2.1, I'm going to use the elimination method to solve. And then for 1.2.2, I will use the substitution method to solve. Okay. Now let's look at this. So I'm supposed to solve this pair of simultaneous equations. So I have y plus 2. Okay, let me just write it out. Y plus 2 equals to 2x, equation 1. And 3x plus 4y equals to 36. Okay, so this is from a Sec 2 Bukit Merah Secondary School question that I've just taken for the explanation of this question. Okay, so I'm going to do elimination. So elimination means I need to make a common term. So let's do that. So common term. Okay, unfortunately, everything here a bit difficult to make common, but I have a 4y and a single y. Okay, so I think maybe I use a different color so it's a bit more contrasting. Yeah, okay, so I have a y and a 4y. So I can actually change this y into 4y. So what I'm going to do, I'm going to take equation 1 and multiply by 4. So by multiplying by 4, I force the whole equation to become times 4. So let's do that. So therefore, 4y plus 8 equals to 8x. Okay, and voila, I have my equation. So I'm going to call this equation 3. So I'm going to compare this equation now and this equation now. Okay, I have two common terms, okay, which is 4y. So I can do a cancellation. Oh, sorry, I can minus the two equations. So let's do that. I'll take equation 2 minus equation 3. Okay, and what you're done with is, okay, let's write it out. So I'll get 3x plus 4y minus 4y plus 8 equals to 36 minus 8x. So when you minus on the left, you minus on the right as well. Okay. So let me just speed this up. So this is 3x minus 8 equals to 36 minus 8x. Okay. 11x is equals to, I think it's 44, and x should be 4. Okay, so this is the first half of the equation. And now we can actually solve the last one. So therefore, let's just do the substitution into 1. So you sub x equals to 4 into equation 1. And what you're left with is y plus 2, equals to 2 times 4, okay, y 6. Okay, and this is the solution. And this is how you do the elimination method. So what I've done here is to get rid of the y, okay, by taking equation 2 minus equation 3, and then afterwards I'm able to throw the x equals to 4 back into the equation and make sure that I can solve out the answer. Okay, so this one is pretty straightforward, so nothing too difficult here. Okay, I'm going to move on. So if let's say you cannot copy fast enough, don't need to worry. This annotated materials will be uploaded. Okay. Okay, I'll move on first. So this is 1.2.2, where I'm going to do the substitution method. Okay. Now substitution is important because we need the substitution method in the syllabus for A math portion. This is only E math portion, so we would need it for the A math side. So that's why let's go through this together. Okay, I have two equations again. So 4x, sorry, bad handwriting. So I have 4x minus y equals to negative 4. 1 over 3, 1 over 3y plus x, 5 over 2. Okay, now I'm going to use elimination, so I have no choice. Okay, let's do some elimination method. So I'm going to use the easier equation and substitute. So I'm going to take from equation 1 because that is clearly easier. So from equation 1, okay, I'm going to get y equals to 4x plus 4. Okay, so that is by throwing the y onto the right and then throwing the negative 4 onto the left, you get 4x plus 4. This is equation 3. You're going to sub equation 3 into equation 2. Okay, and let's solve it up. So 1 over 3, 4x plus 4 plus x equals to 5 over 2. Okay, so okay, this looks a little bit scary. So let's go through it now. Okay, so let's simplify this whole thing. So this will be 4x plus 4 over 3 plus x. Okay, this I'll just write a single x equals to 5 over 2. Okay, and now this is just about equation solving. So let's do it now. Okay, I'll make a common denominator. So common denominator will be 6. So 8x plus 8 plus 6x equals to 15. Okay, so what I have done here is to make a common denominator of 6 by multiplying 2 on the left and 3 on the right. Okay, so what I'm left with here, 12x, I believe is 6. Sorry, no, that's not right. 15 minus 8 is what? 7. And this is 14. Sorry, my bad. Okay, x is half. So 14x is equals to 7, x should be equals to half. Okay, so voila, very good. Now I can substitute. So you sub x equals to half into equation 3. Okay, now you're going to get y equals to 4 times half plus 4. Answer is 6. Okay, so the pair of answers that you will get is x is equals to half and y is equals to 6. Okay, okay, great. So this is the substitution method that I wanted to go through. Okay. Now, I'm not going to go through 1.2.3. So this one I'll leave it to you to do on your own. You can refer to the solutions when they are uploaded. Okay. So this one I will ignore for now. Now, for this portion here, so there are chapters in the AMath syllabus that requires you to solve 2 linear equations. So there are questions here, but I removed it because it's a little bit out of the scope for today. So that's why they are not in this set of notes. Okay, now let's dive into the AMath portion of it. Okay, so this is where the difficulty will scale up by a little bit. Okay, and where you will need the skills of solving non-linear equations. Okay, so let's start with the definition on the top. So what's the definition of a non-linear equation? Now, remember what I said previously? Previously, I said that the definition of a linear equation is where the powers are greater than degree 1. So the powers are degree 1. So for example, x plus y equals to 1, or like 3 plus x equals to 4, those kind of questions. Those are linear equations. Okay, but in the later half of this chapter, you need to know what is nonlinear. So there are definitions of nonlinear. So let me show you. Okay. So nonlinear equations are mathematical equations where it's either if your powers of your unknowns have like a square or a cube. So something that looks like this. Okay, so you have an x squared. Now I know you might be thinking like, how come this is here? How come this one power not greater than 1, but it is considered as a nonlinear? Now there's a reason why, because your y is in your denominator. Now, if you want to make this into like a straight line equation, when I mean straight line as in like no fractions, you will need to multiply y throughout, right? So it'll be x plus 2y squared equals to 43y. Okay, so this one is just a little thing to take note. If you have unknowns in your numerator and your denominator, you need to be a little bit more careful. Okay, these are no longer linear equations. These are actually non-linear equations. Okay. Now, the other condition is that there are other mathematical functions in the equation. So just now remember I mentioned something about like exponential and logarithm. Okay, this is actually what I mean. So there is like a 3 power 2x plus 1 up. Okay, this is a definition of an exponential function. So exponential. Okay, now there's a log here. So this is a logarithm. Okay, and this little e here is also exponential. Okay, and if you look very carefully down here, there's the square root of x, right? Okay, this is your surds. Okay, so I have designed these 3 equations in a way where it actually shows you the introduction to all the other chapters as well. Now, these here are obviously not linear. Okay, they are clearly not linear because you have all of these funky functions inside, okay, that will cause this to not be a straight line. Okay, so yeah, this is the definition of nonlinear equations. So in the second half of this chapter, what you will be given during an AMath exam is a linear equation and a nonlinear equation. So you'll be given a pair of them and then you need to solve. So you need to know how to do it. Okay, now there's another type, okay, that requires this. So sometimes you're actually going to be given like two logarithm equations, and then you need to solve simultaneously. Now, for those, you need to learn the chapter first of logarithms, then you can talk about it. So for now, let's not go into that. We just talk about one linear, one non-linear. Okay? So let's talk about this. Solving simultaneous equations with at least one non-linear equation. Okay? Now, just take note. Remember just now previously I said that for solving simultaneous with two linear equations, which is this page here, what is written here? Three. Okay, there are three methods: elimination, substitution, and graphical. These are the three. Okay, but if you look very carefully, right here, okay, one. There's only one. Okay, and there's no other way to actually solve non-linear equations. And the only way is substitution. So it's exactly what I have done just now. It's just that you need to be a little bit more careful when you're doing your substitution. Okay, so there are little, like 1 to 2 little rules that you need to take note of whenever you are doing substitution for non-linear equations before you can get the answer out. Okay, so that's why this is really important to talk about. Okay, the method still remains exactly the same. You will take your linear equation, okay, and make it a subject, throw it into the non-linear, then you solve it as a final answer. Okay, this is the main steps that you need to take to do substitution. It's literally the same thing as the one I mentioned just now. Okay, now there are some important things to take note of, which is under this tips portion. Okay, so please remember this golden rule. You always use the linear equation to do substitution. You never ever use the non-linear because it doesn't make sense. Okay, I will show you a demonstration of what this means later, but please remember to always use the easy equation and throw it in. Don't ever throw the difficult into easy. It doesn't make any sense at all. Okay, and number two, this is just a personal tip from me. Personally, I hate fractions to the core. Okay, especially when you're doing simultaneous. Okay, because fractions will cause mistakes, and the next 2 pages will show you 4 of the most common mistakes when dealing with fractions. Okay, so I always try to avoid fractions whenever possible, and let me give you an example of when I can avoid. So let me write 2 equations for you. Y plus 2x equals to 3, and let's say I have a new substitution like x squared plus 2xy plus y squared plus 3 equals to 0. Okay, and I ask you to do a substitution like this. Okay, so when I want to do a substitution like this, what I will do, okay, I have two choices. Okay, it's either I do y equals to 3 minus 2x, or x is equals to 3 minus y over 2. Now let me ask you, which one easier? This one or this one? Obviously it's this, right? Because it's a linear equation. Why would you throw a fraction in? Okay, if you can avoid the fraction, please try to avoid, because it's so difficult. Okay, if you throw it in, you must remember so many rules. You must remember that, okay, when you square a fraction, you need to square top and bottom, and you must throw to every single term. Yeah, there's so many things to remember. When instead, when you throw the linear into the non-linear, like this, it's so much easier. You don't need to deal with fractions at all. But sometimes you may need to. When it's unavoidable, then no choice law. Okay, just do it as per normal. Okay, I know someone asked me a question. I'll entertain that question in a bit. Okay, so yeah. Now let's talk about the common mistakes. Okay, I'm coming to the end already. To be very honest, I mean this is just the chapter. The chapter has ended already. Okay, so these are some common mistakes when dealing with nonlinear equations. So the reason why I wrote this into a chapter is because I have many students that make careless mistakes like this. And I can guarantee with you, if you're doing this for the very first time, you're bound to make mistakes like this. So that's why I put it here to make it very clear when these kind of mistakes are, and try your best to avoid them. Okay, so let's start with the first one. To use the nonlinear equation as a substitution tool. So what this means is that people use, okay, I'll show you. Let's say I really have these 2 equations. Some gundus will go and take this y and make it the subject. So they will do like y equals to negative x squared minus 3 minus y squared divided by 2x. Then they throw in. Does that make sense to you? Does that look right? No. Okay, and also there's a y squared here. Okay, you cannot do that. So there are people that do that when they are very desperate. Okay, and that is something that you should never ever do because you will 100% get stuck. Okay, so this is a common mistake. Please do not make this mistake. Okay, so this is the first one. Number 2, usage of algebraic identities. What does this mean? Okay, the next 3 rules are talking about fractions. So in the situations where fractions are unavoidable, okay, let's look at this example together. So x plus 2 over 3 whole thing squared plus 3y equals to 7. Okay, now your objective is to definitely expand. So I'm going to expand it. Okay, and what do I see here? Okay, some people will actually get this as an answer. Okay, the numerator, x squared plus 4. Is this true? No, okay. A plus b whole thing squared is not the same thing as a squared plus b squared. Okay, you must remember that this is the same thing as a squared plus 2ab plus b squared. Okay, must be very careful because sometimes when you are dealing with fractions, you go and see the square on the outside, you completely forget that you need to use algebraic identities to go and open up the bracket. So please be very, very careful. And especially right now at this stage, you are going to be using non-linear equations and you're going to be facing non-linear equations. You must remember that at every step, you need to use the algebraic identities or else there's no way you can solve the question. Okay? So the identities are here. Please remember to use these two. Okay. So the next one, squaring the denominator. This is another super rookie mistake that a lot of people make for no apparent reason. So I give you back the same equation, x plus 2 over 3 whole thing squared plus 3y equals to 7. Okay, now this is what some people will write. Okay, the incorrect step, which the denominator is still a 3. Okay, is this correct? No. Okay, you must remember that when you are squaring an entire fraction, your top and bottom must be squared. Okay, if it's not, you will confirm cock up. Okay, so it's supposed to be a 9. And the reason why I mention this is because a lot of people in their head, right? Okay, when they do this, okay, they will remember, okay, x plus 2 must use algebraic identity. Then the bottom completely forgot you got a square. And then you will just go and write a 3. And then you'll get the whole question entirely wrong. Okay, so please be very careful. Remember that when you have a square on the outside of a fraction like this, you need to square the numerator and the denominator. Okay, so please be very careful. Okay, the last one is about this. This is not really a rookie mistake, but this is a common mistake that I think is worth mentioning. Okay, which is talking about the multiplication of the constant throughout the equation. What does this mean? Whenever you're dealing with a fraction, okay, after you have squared the denominator, you have a number at the bottom. Okay, your next step is to linearize this equation. So it's to make everything into a beautiful straight line. Okay, and how you do that is by getting rid of the denominator by multiplying this 9 out. Okay, but sometimes people will only remember to multiply across the equal sign, and then they will forget about this. Or they have like one tiny hidden term right here, like for example, a lonely x, and then they completely forget to times, and then you'll get it wrong. Okay, so please be careful. Whenever you are opening up your brackets, okay, you are opening up the denominators into the rest of the terms, you need to ensure that every single term has that denominator multiplied. So as you can see, the 3y and the 9 times 3y, every single term must be multiplied. Okay, so please be very careful. Now, these are rookie mistakes, so please do not make them. When you are learning other chapters and when this particular concept comes back again, and you need to use this concept of simultaneous to solve the question, you need to remember these rookie mistakes that a lot of people make and do not make it during exams. Okay, and we are done. That's the chapter. Okay, so right now, I'm just going to cover one of the questions, which is this particular one here. Okay, and the rest I will just leave it up to you to try. Now I've removed the last 3 pages of the notes. When I sent it out when I uploaded the notes in the morning, I included the last 3 pages, but I decided to take it out. So, excuse me, you can just ignore them. I will just be attempting this first question here. Okay, so this is a general kind of A math question that you will see in exams. Okay, so the question says what? Find the solutions of these simultaneous equations given that this. Okay, take note that whenever you are dealing with a non-linear simultaneous equation, you can get multiple answers. So sometimes you will have like 2 answers, 3 answers, 4 answers. You need to be really careful. Okay, so I'm going to demonstrate how to do the substitution, but I believe everyone already knows how. So 3x plus 4y equals to 8. 6x minus 20 squared plus 4y plus 3 squared equals to 200. Okay, this is the question. So right now I'm going to do the substitution because that is the only way I can solve this question. Now, please remember, okay, there is no way you can take this and throw in here. It is impossible. Okay, so we will always use the non-linear and do the substitution. Sorry, use the linear and do the substitution. Sorry about it. Okay, so let's do it. So, how to do? Now, first thing I notice is that I have a 4y here and I have a 4y here. Okay, very good. So instead of making like a y into a fraction, I can just use the 4y straight. So from here, I'm going to get 4y equals to 8 minus 3x. So that's my first equation. So I'm going to call this equation 1 and equation 2. Okay, and now I'm going to do the substitution. So you sub equation 1 into equation 2. Voila. So let's write it now. 6x minus 20 squared plus 8 minus 3x plus 3 squared equals to 200. Okay, so right now we have a quadratic equation. So let's simplify this. Okay, now remember, because these are all squared terms, you need to use identities. So let's do that. 36x squared minus, 240 if I'm not wrong, plus 400 plus my life math abilities. 121 minus, okay, it's only calculator, sorry, 11 times 3 times 2. Negative 66x, correct, plus 9x squared equals to 200. Okay, so this is my equation here. And now you just need to simplify. Did I miss something out? There's a missing x. Okay, so this is the equation. Next, group everything together. So 36 plus 9, 45x squared. Okay, negative 240 minus 66, negative 306 x. Okay, and then there's a 400 plus 121 minus 200. So you will be plus 321 equals to 0. Okay, so very good. Now let's check whether this equation got answers. Should be. Okay, so it's 45, negative 306, 321. Okay, yes, there are answers. Okay, so you just need to solve this out using the quadratic formula. Okay, but unfortunately you cannot do it now. So I'll leave this as it is. Okay, so you just solve it out using either the box or the quadratic method, and you can get your answers for x, and then you can substitute to solve for y. Okay, I don't think I made a mistake, right? Yeah, it should be all correct. Okay, so this is the main gist of what things are supposed to be like. Okay, you're supposed to get an x answer out and you're supposed to get a y answer out. And then once you're done, that is the full solution for the question. Okay, so this is basically the main introduction into simultaneous equations. And then once you have completely mastered this topic, then you will start to move on to the other topics already. Okay, so yeah, I think I'm just going to end here. I think this is a good ending point. Okay, so the remaining of the questions, like unfortunately right now, I don't have the time to go through, but what I will do is that I will upload the typed out answers for all of these questions here and put it into the Dropbox. I will only do so tonight after the AMAth, the Sec 4 AMAth session. So hold out for a while and then you will be able to see the solutions there. Okay, now, let me just wrap up this whole session and then we can kickstart the Q&A. So yeah, let me see. Okay, so basically what I just want to say next, okay, is that I just want to wish everyone all the best. Okay, happy Christmas, happy New Year. Okay, and wish really everyone all the best in taking AMAth. I hope that today's session was informative. You guys learned a little bit something new from the simultaneous chapter. Okay, this is really just a little tickle of how the chapter is supposed to be like. Okay, and I hope I have piqued your interest in the subject and you will take some time to go and read through the materials given and whatsoever. Okay, So just want to say one last thing. So these are the kind of materials that I give my students. So I will give them lecture notes, tutorial questions every week to do, class tests that I set once the exams are coming. Okay, I will give answer key out. So my answer keys will look like this. That I'll provide the full worked out solutions. You can see them tonight after I've uploaded them. And you will also get like a lot of resources. So questions, revision packages, quizzes, school papers, and whatsoever. Okay, so without further ado, okay, this is the end. Now, before you leave, okay, just take note that next week, Monday, I will actually be conducting a trial lesson. So this is slightly different from today's lesson. The trial lesson is completely free. Okay, so today's one is a little bit more chill, a little bit more relaxed. Okay, but for next week's trial lesson, I will actually be going a little bit deeper into simultaneous, and I will also be touching on a new topic if possible. Okay, so the next week's trial lesson is completely free as well. It's on Monday, 7:30 p.m. to 9:30 p.m. Okay, you can sign up on the QR code here. Okay, so this is if you're interested in the lesson, or if you want to 100% go for me as a tutor to teach you for the next year, then you can also sign up in the link. I will contact you tomorrow and you let me know. Okay. So for my weekly tuition, so this is advertising for my group tuition. So it will happen on every Tuesday, 7:30 to 9:30. Okay, this will happen after the EMAF. So EMAF will be from 4:30 to 6:30, then a dinner break for 1 hour, and 7:30 to 9:30. Okay. Tentative will start on the 4th of Jan, so that will be in 3 weeks' time. And the location most likely will be in Toa Payoh, okay, at this location called Spatial Collective. If there are any changes or let's say COVID prevails, then we will host it online. My fees is $40 per hour. It's the same throughout everyone in Overmark. So all the subjects are the same. Okay, and there's a special discount going on. If you sign up for both A and E, you'll be entitled to a 10% discount. Okay, so that's about it. Okay, really that's all from me. So if you're interested, I have a curated notes as well. If you want, you can order the notes. It contains about the same things. If you're interested, I can show you what these look like. Okay, and also the trial lesson is right there. Okay, so that's all for today. I'm going to stop the recording